Okay, here's some identities that we call the double angle identities. And it looks like there's a whole bunch here, but there's not as many as it looks. So let's talk about it. First of all, cosine of 2a is cosine squared a minus sine squared a. Kind of reminds me of the Pythagorean identity. It looks like a variation on that. And if you can kind of remember it that way, just remember that you're subtracting here instead of adding. And you get the double angle. That's cool. If you can remember this one here, and this one here follow directly from it. If you remember the Pythagorean identity that cosine squared is just, or that cosine squared plus sine squared is 1, and if you remember that cosine squared can be rewritten as 1 minus sine squared, then you have 1 minus sine squared, which is 1 minus 2 sine squared. Okay, and then if you replace it the other way, you get this one. So if I replace the sine squared with 1 minus cosine squared, I get cosine squared minus 1 minus a negative, which is a plus, so I end up with a 2 cosine squared a minus 1. So these two, I call those essentially they're corollaries, right? If you got this one, then these two just follow on. So really, this one, sine 2a is equal to 2 sine a cosine a, and that one's pretty easy to remember. It's probably one of the most straightforward identities in the bunch. And this one looks very similar to the ones we had previously when we were talking about the sum and difference identities. And I think you could probably see if tangent of 2a is really tangent of a plus a, that's a sum, right? And so we could just kind of directly derive it. If you remember the sum and difference identities, you could probably get this one straight from that. So not a whole lot new here, just a few more identities to throw in your toolkit, so when we're actually doing some of these problems, you've got more stuff to work with. And that's all for this video.